A late problem. Water is flowing into a conical vessel at the late hour. The water is flowing into a conical vessel at the late hour. The vessel has the shape of the A light circular cone. With a horizontal base, the vertex painting the downwards. The radius of the base is altitude of the cone B. Find the rate at which the surface is rising when the depth of the water is y. Finally, obtain the numerical value of the unknowns, supposing that unknown. Finally, obtains the numerical value of the unknown, supposing that A equal 4 feet, B equal 3 feet, R equal 3 cu ft per minute, and Y equal 1 feet. The students are supposed to know the simplest rules of the differentiation and the notion of the rate of change. What are the data? The radius of the base of the cone A equal 4 feet. The altitude of the cone V equal 3 feet. The rate at which the water is flowing into the vessel R equal 2 cu feet per minute. And the depth of the water at a certain amount y equal 1 feet. Correct the statement of the problem seems to suggest that you should disregard provisionally the numerical values, work with the letters, express the unknown in terms of the A, B, R, Y, and only finally, after having obtained the expression of the unknown in the letters, substitute the numerical values. I would follow this suggestion. Now, what is unknown? The rate at which the surface is rising when the depth of the water is y. What is that? Could you say it in another terms? The rate at which the depth of the water is increasing. What is that? Could you restate it still differently? The rate of change of the depth of the water. That is right, the rate of change of the y. But what is the rate of change? Go back to the definition. The derivative is the rate of the change of the function. Correct. Now is y a function? As we said before, we disregard the numerical value of y. Can you imagine that y changes? Yes, y, the depth of the water, increases as the time goes by. Thus, y is a function of the what? Of the time t. Good. Introduce suitable notation. How would you write the rate of change of y in mathematical symbols? dy over dt. Good. Thus, this is your unknown. You have to express it in terms of the a, v, r, y. By the way, one of these data is a rate. Which one? R is the rate at which water is flowing into the vessel. What is that? Could you say it in another terms? R is the rate of change of the volume of the water in the vessel. What is that? Could you restate it still differently? How would you write it in the suitable notation? R equal dv over dt. What is v? The volume of the water in the vessel at the time t. Good. Thus, you have to express dy over dt in terms of the AV, dv over dt. Why? How will you do it? If you cannot solve the proposed problem, try to solve the first some related problem. If you do not see yet the connection between the dy over dt and the data, try to bring in some simpler connection that could serve as a stepping stone. Do you not see that there are other connections? For instance, are y and v independent of each other? No, when y increases, v must increase too. Thus, there is a connection. What is a connection? Well, v is the volume of the cone of which the altitude is y. but I do not know yet the radius of the base. You may consider it, nevertheless. Call it something, say x. V equal pi x square y over 3. Correct. Now what about x? Is that independent of y? No. When the depth of the water y increases, the radius of the free surface x increase too. Thus, there is a connection. What is a connection? Right. Of course, similar triangles x to y equal a to b. One more connection you see. I do not miss profiting from it. Do not forget, you wished to know the connection between v and y. I have an x equal ay over v, v equal pi a square y to the third power over 3 to the b square to the b square power. Very good. This looks like a stepping stone. Does it not? But you should not forget your goal. What is the unknown? Well, dy over dt. You have to find the connection between dy over dt, dv over dt, and other quantities. And here you have one between y, v, and other quantities. What to do? Differentiate, of course. Yes. dv over dt equal pi a square y square over b square times dy over dt. Here it is. Fine. And what about the numerical values? If a equal 4, b equal 3, dv over dt equal r equal 2, y equal 1, then 2 equal pi times what is y equal I, then 2 equal pi times I6 times I over 9 times dy over dt.